Okay, in this video we are doing part 4 of problem set 10 from my Calc CD multivariable class. We are doing tons and tons of line integrals, and let's just dive in because at this point we probably know what we're doing, and hopefully you're just watching to, I don't know, compare your work to mine or, see another perspective. So we have f, the vector field, 3z y to the negative first, or 3z over y, I guess, 4x and negative y, and then we have e to the t, t, and we're going from negative 1 to 1. So it's a vector field, so we have to find f of r of t and then dr, which is r prime of t dt. So let's do that. So f of r of t, I'm just going to dive in and do it. And still color coding. It's going to be blue for x, purple-ish for y, and then orange-ish or peach or something for z. So you will end up with 3t e to the negative t, 4e to the t, negative e to the t. And then we need to find dr, which is r prime of t dt. Go back to r, don't use f of r of t. So that's going to be e to the t, 1, and then dt. So the line integral f dot dr is going to be the integral from negative 1 to 1, the actual dot product, f of r of t dot dr. Now we do the actual dot product, and we will end up with the integral from negative 1 to 1 of just do the dot product. You end up with 3t, because e to the t and e to the negative t kind of cancel out or multiply to 1. You get 4e to the 2t, and then you get minus e to the t. dt. Integrate. So we got to reverse the power rule. We've got to do a u substitution, and then the antiderivative e to the t is e to the t. From negative 1 to 1, plug in 1, we get this. Plug in negative 1, we get this. Clean it up. It doesn't really clean up very much. We get 2e squared minus 2e to the negative second plus e to the negative first. I guess. I mean, that's what we get. All right, next up. F is the vector field, negative y over quantity x squared plus y squared squared, comma, x over quantity x squared plus y squared squared. This feels very polar. Like I didn't do anything with polar, but it feels very polar. Over the circled radius capital R, centered at the origin counterclockwise. Okay, so centered at the origin counterclockwise. Notice it doesn't tell us where to start. So I'm just doing normal unit circle because that's what happens, right? So here's kind of a picture. This is the radius. It's capital R, which is so annoying. So r of t, because there's enough r's already. R of t, I'm just going to do capital R cosine of t and capital R sine of t. And this will go from 0 to 2 pi. Okay, so we got to calculate f of r of t. So y is r sine of t. And then x squared plus y squared is r squared cosine squared plus r squared sine squared, which is r squared cosine squared plus sine squared, but cosine squared plus sine squared is 1. So that's just r squared. And then we have to square it. So that makes the denominator of both things just r to the 4th is basically what's happening there. So we're going to get negative r sine of t over r to the 4th per the previous conversation. And then r cosine of t over r to the 4th. All right, we have to find, we should find r prime of t, but r prime of t is just going to be negative r sine of t, comma r cosine of t. So I'm going to jump in and do the line integral instead. All right, so it's going to be from 0 to 2 pi, f of r of t, dot r prime of t is negative r sine, comma r cosine, and then dt. All right, so if you think it through, when we do this dot product, we're going to end up with, there's an r times an r for every calculation. So there's an r squared just sitting in the numerator. And then we'll have sine squared plus cosine squared. So it'll look like this. You can cancel the r squared and the r to the 4th to be 1 over r squared. And sine squared plus cosine squared is 1. So really we just have 1 over capital R squared dt. So t is our variable. So this is going to give us 1 over r squared t from 0 to 2 pi, which is just going to be 2 pi over r squared, which is what we get. So it's a weird setup for a problem, but not a big deal. Let's look at another one. All right, vector field 1 over y cubed plus 1, comma 1 over z plus 1, comma 1. This is a little gross. r is t cubed comma 2 comma t squared. So I'm not even going to color code this one because I think we know what we're doing at this point. Let's just go for it and hope it. It's pretty straightforward, right? We're doing the integral along c of f dot dr. So we're going from 0 to 1. And then y is equal to 2, so that's 1 over 8 plus 1, 1/9. Comma, z is t squared, so 1 over t squared plus 1. And then it's just 1, so, doesn't matter what you were dealing with, just stays 1. Dot, we need r prime of t dt, so 3t squared, comma, 0, comma, 2t, and dt. Do the actual dot product. So this is, once you get the hang of it, like, they go faster than me, I guess, than how long I'm taking to do all these. But I'm trying to explain everything as I go. So 0 there, and then just 2t. All right, reverse power rule. We get this, sub in, we get this, and that's just going to give us 10/9. So that's a very straightforward problem. Like, hopefully you can see that and deal with it immediately. Let's look at number 26. All right, this will be the last one in this particular video, and then I'll be back for like part 1 million. All right, the vector field z cubed comma yz comma x. Circle in the yz plane of radius 2. Y is greater than or equal to 0. Z is greater than or equal to 0. Clockwise when viewed from the positive x-axis. So I don't know. I'm pretty sure that I thought about this correctly. I graphed it in GeoGebra after I wrote these, and I'm pretty confident that this is the right thing. So I redrew this, and I just put like x here, y, and z here. So this is like the easiest perspective to kind of work this out for, I believe. We want this, right? We are going y and z are both positive, and we are going clockwise when viewed from the positive x-axis. But that's like the way the 3D coordinate system is usually drawn. So I don't think this one is super hard. There's another one somewhere in this problem set where it's like a random thing or something. I don't know. All right, so this, I'm just going to say r of t. We're in the yz plane, so x is definitely 0. Now, z starts at a maximum. Okay. We should do x then y then z like normal people, right? Y is starting in the middle and increasing to its maximum, so that's going to be sine, so 2 sine of t. Z is starting at its maximum, and that's going to be cosine every time, so 2 cosine of t. All right, so I graphed that in GeoGebra, and I'm pretty confident that it's doing exactly what the description should be, so let's dive in and do it. So our line integral is going to go from 0 to pi over 2, because it's just a quarter circle, and then f of r of t, so it's going to be, z is 2 cosine, so it's going to be 8 cosine cubed, and then comma, y times z is 4 sine cosine, and then x is just 0, which is good because we're going to dot this with r prime of t. So r prime of t is going to give us 0, comma, 2 cosine, comma, negative 2 sine. So remember, you go back to r for that. What's nice is that each of these vectors has a component that is 0, and they are not the same component. So all that's left when we do the dot product is like the y parts times the y parts. So we will get 0 to pi over 2, 8 sine times cosine squared. That's all that remains. And then this you could do like straight u substitution, u is cosine, I guess. You'll get negative 8/3 cosine cubed. And then from 0 to pi over 2, cosine of pi over 2 is 0, and the cosine of 0 is 1. So we will get negative 8/3 quantity 0 minus 1, which gives us positive 8/3. That's the last one that I want to do in this because the next couple are sort of different looking. All right, so I'm going to end this here. I hope this was helpful, and good luck.